on intuition until a certain degree. Yet what's best, it's when data supports your choices. It can be applied to finance and reconciliation, to HR, cost center attribution, calculations. R&D also requires tons of data to support the decisions, for example, about the direction of game development, etc. Okay, time to delve into what are different types of data available in your landscape. First and most important are what we call transactions, which always come in huge volumes. Usually we speak about millions or billions of transactions. And these are all types of actions that players, and not only players, perform. In the context of the core business activities, think about bets, wins, deposits, withdrawals, bonuses, redeemed, played, converted, coupons, redeemed. Remember that any other system or action can generate transactions. Say food and beverage purchases, any other financial data, or any calls that players make to your customer service team. Player entries are transactions too, captured both online and offline in the land-based world. In case of online, it's much easier to capture them. For the offline, you might require changes in the business process and the interaction with your software so that you fully capture who enters when and how often if you want to be efficient in these measurements. After the transactions, you have master data. Master data, which is all the descriptive information about your various business entities, player or customer, including KYC information. Then you've got data about your products, and also you have an analyzed vendor or supplier master data. These always carry less volume, but much more complexity. Master data, when correctly organized and governed, will facilitate your life whenever performing omnichannel analysis and marketing. As one of the core applications of, for example, customer master data is identifying the single, or we say golden record for your customer and allow personalized profile targeting. Moving on to the third type of data, reference data. This is a type of data often overlooked, but if you have discrepancies and misalignment in your reference data, it's highly likely you will stumble upon some inconsistencies in your numbers. Reference data are postal codes, countries, regions, languages, currencies, segments, or categories. Finally, one last consideration. Your data can be either structured in a specific format suitable for searching or unstructured. Emails, photos for image recognition, social media posts, documents and text, soundtracks, these are all types of unstructured data, which you can store and leverage and discover new insights. Apply natural language programming to perform sentiment analysis on your social media posts. This could be one of the applications. Think also about such a use case. Analyzing video footage from a specific player allows you to track the performance of a single player in the land-based scenario. Also, you could discover what are the areas of your floor that get the most traction and therefore adjust the way how the machines are distributed across your floor, all thanks to video data. So here we are. Now that you know you have a lot of data to tap into, the next question is, which tools to select in order to be successful? You might think, but hey, how can I assure that I will choose my technologies wisely and that I won't need to make a U-turn on them? For this reason, you'll need to answer a few questions to begin with. At this stage, the first and foremost question is buy or make. This applies to the gaming sector in the same way as it would anywhere else. Buying means relying on products which provide some solutions out of the box. This is something that gives you results fairly quickly, although limited in scope and capability. For small setups, when you have, say, maybe 1 million transactions altogether, you might not necessarily be in a position where you want to implement anything tailor-made. Therefore, buying a product is the way to go, as it relieves you from the necessity of having a BI specialist on your end, and it will already provide you some value. Still, you need to be aware that any product will need to be adapted to your tech stack and will need to be mapped to your data sources, systems, and taxonomy, which might not always be technically feasible or available. So first option was buy. Now let's examine the make option. Here by making, I do not consider building your own tools, rather implementing existing top-class tools and tailoring them to your specific needs. For anything related to data analytics, you would rely on solid technologies built on top of decades of experience of the big tech, like Microsoft, Amazon, or Google. Moreover, you could leverage multiple open source technologies developed by the Vibrant community as either the foundation or complement to your technological stack. An example would be implementing Power BI, the market leader in reporting, as your data visualization tool. Power BI is a Microsoft product used by thousands of customers, and there's millions of applications of it, and it is the reference in the whole technological industry. Why would you then even bother buying other things or trying to replicate it by yourself? Just get it and implement it. Usually, in such implementations, you would rely on your internal data team or external partners that bring in the expertise and allow you to scale your capacity to deliver such a project. This allows you to accelerate the digital transformation and benefit from the new capabilities way faster based on blueprints and technological standards brought by your partner. After buy or make, another key consideration: going to the cloud or using your own servers. While in most cases, people opt for cloud solutions because they offer much more flexibility, especially in the context of a dynamically changing business environment. The time to market is definitely faster, and cloud allows you better scalability, as you can either add servers or buy more powerful servers, so scale out and scale up. Cloud also easily accommodates new functionalities and features and allows much more extensibility from the get-go. On the other hand, you might be tempted to opt for going on-premise and using your own servers. This option may often seem cheaper. Also, this does not need to be the case if you take into account the TCO of such choice. You will need someone to manage those servers. You'll need to have enough physical space. Ensure security, surge protection, fire protection, cooling, and on top of that, server memory and storage space is not easily scalable and might require downtime for scaling. While in the case of cloud, it's just a fraction of the time needed. If you want to scale, you'll tend to overpurchase for the current needs in order to anticipate future requirements, but then you end up paying for something you do not entirely consume. This is due to the fact that purchasing new machines simply takes time, and that's why in most cases, cloud is the way to go. Important side note: consider building a roadmap before you start the implementation. This way you avoid encountering bottlenecks in enterprise architecture and you save yourself at least a few months of work. An incorrect choice at the beginning strikes back after some time, and you return to the first step yet again, just with time and money spent for nothing. Now let me add in a few points about what are the most popular technologies for data and analytics. Consider 3 areas: loading data, storing and serving, and consuming. For data loading, you can rely either on the classics like ADF, Cloud Data Fusion, or refer to tools such as Stitch, Airflow, or dbt. Then you've got the store and serve tools: data warehouses, data lakes, lakehouses, with the classics such as Synapse, Snowflake, Databricks, and many others. Finally, consuming data can be done either by your ML applications or by reporting tools, such as Power BI or Tableau. Last but not least, let's discuss what are the typical challenges when working with data. First thing that comes to my mind is data volume. Especially in the context of transactions, typical enterprise cases will include billions of records and entries in your source systems. All that data needs to be stored and processed efficiently so that it can be made available to your business users for building reports, analysis, and gaining powerful insights. One aspect is how much data you have, but another is about the velocity of how much new data you generate. And this matters especially for newly established businesses with rapid market expansion and growing customer base. Making good technological and architecture choices will enable you to leverage your data fast and reliably. Modern technologies enable processing incredible amounts of data, but it always boils down to choosing the sweet spot between performance and price. After data volume, the second most important challenge is about the data quality. In short, good data quality makes your reports meaningful. On the other hand, poor data quality, such as gaps, incorrect, incomplete values, duplicates, other inconsistencies, basically they prevent you from making any rational decisions based on your data, as data without data quality is simply useless. And in order to ensure high quality of your data, you'll create rules and responsibilities for your data as part of a data governance program. Such program needs to have organizational alignment and top-level support, as this will impact the whole company across all functional areas. It is a vital initiative as it will directly impact any efforts related, for example, to omnichannel and multi-source harmonization. Finally, third and last typical challenge is about the adoption. I have seen way too many times great reports that simply no one uses in the company. No matter how marvelous data you create from an engineering perspective, if nobody uses it after, it makes no sense to maintain it. Your solutions need to be business driven, and the requirements such as business cases must be at the core of your approach to data and analytics. Also, implementation is always followed by an adoption program so that people learn the new ways of working and so that your data starts to drive business decisions. Wow, glad that you made it all the way until here. So, as we're slowly wrapping up, let me bring up the key takeaways from today. First, we discussed what does data analytics and governance mean. Then, we briefly spoke about why data is important and how it applies across various functions of iGaming businesses, such as marketing, customer service, responsible gaming, compliance, etc. We also discussed what are the different types of data: transactions, master data, reference data, and unstructured data, such as videos or images. After, we covered selected common considerations when making technological choices for data, and we discussed what are the typical challenges with data and how to address them. That's going to be it for today, so guys, no more bets. This is Stan signing off for now, and remember, keep rolling with the data.